Today, we want to solve a given P.D.E equation using an auxiliary equation. And let us consider the given equation, the given P.D.E equation, that is P.D.X plus Q.D.Y plus R.D.Z is equal to 0. Making this as our example or equation 1, not example 1. From this, we can obtain an integrability equation that will help us check if a given P.D.E equation is integrable. That one we're going to get this way. We're going to hold P.D.X, but taking the coefficient of the x, that is P, you multiply by the partial derivative of Q with respect to Z, that is partial derivative of Q with respect to Z, minus partial derivative of R with respect to Y, partial derivative of R with respect to Y, plus we add it. We're adding that one, we're going to hold next, that is Q. You multiply by partial derivative of R with respect to X, that is partial derivative of R with respect to X, minus partial derivative of P with respect to R, partial derivative of P with respect to partial derivative of P with respect to Z, partial derivative of P with respect to Z, plus we hold on R, we write it, we multiply by partial derivative of P with respect to Y, partial derivative of P with respect to Y, minus partial derivative of Q with respect to X, and this should give us 0. Let us make this our equation 2. Having obtained equation 1 and 2, we want to obtain our auxiliary equation. And how are we going to obtain our auxiliary equation? We are going to compare equation 1 and 2 and solve them simultaneously. And if you have solved them simultaneously, we obtain the auxiliary equation in the form dx all over partial q all over partial z minus partial r all over partial y, and this one is equals to dy all over partial r with respect to x minus partial p with respect to z. This one is equals to dz all over partial p with respect to y minus partial q with respect to z. After obtaining that, we make it our equation 3, but it is equated to 0. This one is our equation 3. After obtaining the auxiliary equation, you can solve this equation using the previous methods or techniques, where you can use the multipliers or taking the first and second equation, that is first and second, first and third, for you to obtain C1, the constant one, and this constant one we will equate it to our u. It will be our u, and then again you get constant 2, which is our v. After obtaining u and v, we differentiate them. If you differentiate u, we get du. Then if you differentiate v, we get dv. From this, we are going to formulate an equation a du plus b dv, and this one should be equals to 0. This is our equation 4. Let us make it to be our equation 4. After reaching this point, you obtain the values of A and B. After obtaining the values of A and B, how are we going to obtain the values of A and B? By just substituting the du in this equation, the dv in this equation here, and then you compare equation 4 with our initial P.D.E equation 1. How are you going to compare? You're going to obtain the dx after rewriting this equation and rearranging it, and you are going to get your required solution after integrating. Let us take example 1. Let us solve an example 1. You say use an appropriate auxiliary equation to solve xz cubed dx minus z dy plus 2y dz equals to 0. This is our given P.D.E. Let us check for the solution. First of all, you have to identify your P. Our P is xz cubed. Our Q is negative z, and our R is equals to 2y. Having this, we use the auxiliary equation up here to solve the given P.D.E equation. We're going to solve the given P.D.E equation taking the first one, that is the x all over partial q with respect to z. What is our q? This here. With respect to z, it will be negative 1 minus partial r with respect to y. What is our r? R is here. If we differentiate it, it will be 2. We equate this one to dy all over partial r with respect to x. Partial r with respect to x, that is 0, minus partial p with respect to z. Partial p with respect to z, we get 3x z squared is equals to dz all over partial p with respect to y, that is partial p with respect to y, that is p with respect to y, you get 0, minus partial q with respect to z. Partial q with respect to, sorry, it should be partial q with respect to x. Point of correction. Partial q with respect to x, partial q with respect to x, we get 0. Simplifying this, we get the x all over negative 3 is equals to dy all over negative 3xz squared is equals to dz all over 0. So we want to solve for our C1 and C2. How are we going to solve? Let us taking our first and third, that is the x all over negative 3 is equals to dz all over 0. We multiply all through this equation by negative 3 for us to get the x is equals to negative 3 dz all over 0. We again multiply the x with 0. we are going to get 0 is equals to negative 3 dz. Let us do away with the negative 3. That is dz, our dz will be equals to 0 after dividing all through by negative 3. Then at this point we integrate. If we integrate, we obtain our z is equals to c1, and this one we equate to be our u. Again, taking our first and second, we get the x all over negative 3 is equals to dy all over negative 3 x z squared. We do away with the common one, that is negative 3. They will cancel for you to remain with the x all over 1 is equals to dy all over x z squared. At this point, rearranging this, we will have our x z squared dx is equals to dy. That will be the x z squared dx minus dy is equals to 0. At this point, we integrate. Integrating this, we obtain this one with respect to x, this one with respect to y. We're going to obtain x squared all over 2 z squared minus y is equals to c2. Multiplying all through by 2, we get x squared z squared minus 2y is equals to c2, and this one we make it be our v, as we said earlier during the introduction. This is our v. And then what we do next, we differentiate our u and v. So our u was z, somewhere we obtain it at this point, and our v was, where did we obtain our v? Our v was x squared z squared minus 2y. If we differentiate our u, we get du is equals to dz, and then this one we are going to differentiate totally, of which we are going to apply the product rule. We get 2x z squared dx plus 2x squared z dz minus, if we differentiate this, we get, with respect to y, we get 2. That's our d. That's our dv. That's our dv, and this one should be, if we differentiate it, it will be 2 dy at that point. Getting our dv and du, we substitute in the equation that we're going to formulate, that is a du plus b dv is equals to 0. That will be a dz, since our du is equals to z and our dv is all of this. That will be plus b into 2x z squared dx plus 2x squared z dz minus 2 dy. We close the bracket. This should give us 0. And that should give us 0. Let us make this one our fourth equation. Since our first equation was the given P.D.E, it was the given P.D.E equation. It was the given P.D.E equation. So rearranging this, we will have a dz plus, opening the bracket, to get b 2b x z squared dx plus 2b x squared z dz minus 2b dy is equals to 0. Let us rearrange this in form of pdx plus q dy plus r dz. We are going to obtain 2b x z squared dx plus, it will be minus 2b dy plus a. This one will be a bracket, since dz we have 2 of them, plus 2b x squared z dz is equals to 0. Then we compare this equation with our initially given equation, the P.D.E equation that was given, that is z x z cubed dx minus z dy plus 2y dz is equals to 0. This was our P.D.E, given P.D.E equation. If we compare it, we're going to compare by taking the coefficients. We're going to compare it by taking the coefficients of dx, that is x z cubed is equals to 2b xz squared. Again, we compare the coefficient of dy, that will be negative 2b is equals to negative z. Again, we compare this, that will be 2y is equals to a plus 2b x squared z. So from this point we can obtain the values of a and b. Let us obtain the value of a of b from this, the first one or the second one, the easiest one. Let us take the easiest one to be negative 2b is equals to negative z. To obtain our value of b, our b will be z all over 2. By dividing all through by negative 2, you obtain the value of b. Since we have the value of b, we are going to substitute to the given equation or the compared equation to obtain the value of a. So the value of a, we are going to obtain it this way. Minus 2y is equals to a plus 2. So wherever there is b, we replace with this. So it will be 2 dot z all over 2 times x squared times z. So the 2's are going to cancel. We are going to remain with 2y is equals to a plus x squared z squared. That is the value. We have not yet obtained the value of a. So our a will be equals to 2y minus x squared z squared. That is, if you have taken x squared z squared the other side of the equation, and this is our a, the value of a. This is the value of b. But from whatever we are obtaining, we know that the value of z was equated to u, and the value of v was equated to this. To mean, if we multiply this by a negative, we will get the value of our v. So this one here, the value of a, if we multiply it by negative, we are going to get the value of our v. So this one will be negative v, and then this one will be our value of b will be rewritten this way, u all over 2. Up to that point, we are going to substitute the value of a and b in our formulated equation. That is, the value of a will be, our formulated equation was a du plus b dv is equals to 0. Replacing the value of a and b, we get negative v du plus u all over 2 dv is equals to 0. Rearranging this, we take the negative sign on the other side of the equation. We obtain u over 2 dv is equals to v du. We multiply all through by 2, we get u dv is equals to 2 v du. Rearranging them with respectively according to their derivatives, we obtain dv all over 2 v is equals to du all over u, We rearrange whatever we have got there, so it will be dv all over 2v minus du all over u is equals to 0. At this point, we integrate. When we integrate that, we come up with ln v we obtain 2 ln v so if we integrate this, we obtain ln v all over 2 minus ln u is equals to ln c. Multiplying all through by 2, we get ln v minus 2 ln u is equals to ln c. Using the laws of logarithm, we are going to combine this, of which it will be v all over u raised to 2 is equals to c. Rearranging it, we get v to be equals to our c u raised to 2. But we know that from whatever we obtained, that is, from whatever we obtained, we have our value of v and our value of u to be z. We are going to substitute the values of u and z in whatever we have got here. So it will be, the value of v is x squared z squared minus 2y. We equate that to be a constant c z squared. Reaching that point, we get the required solution, taking C1, C2 and C as an arbitrary constant. Thank you, and let's solve another example in our next video.